In section 3.1, we look at reference angles and its implications to trigonometry. The definition of a reference angle, or sometimes it's called a related angle, is that for any angle theta in standard position, this reference angle is the positive acute angle between the terminal side of theta and the x-axis. In this book, when we talk about a reference angle for an angle theta, we will denote the reference angle as theta hat. That's what I call this little symbol here. So let me give you a generic example. Suppose we have an angle theta in standard position, and let's suppose that this angle theta terminates in the second quadrant. By the definition, the reference angle is the positive acute angle between the terminal side of theta and the x-axis. So for this particular angle, this would be the reference angle, and we would call this angle theta hat. And theta hat is a positive acute angle, so that means it must be between 0 and 90 degrees. Let's take a look at some specific examples. So here we want to find the reference angle for each of the following angles. We have the angle 30 degrees, 135 degrees, 240 degrees, and 330 degrees. And here you can see for the angle 30 degrees, which is an angle that terminates in the first quadrant, the reference angle is the angle between that terminal side and the x-axis. And of course, if the angle itself is 30 degrees, the angle here is also 30 degrees. So the reference angle for an angle in the first quadrant is basically the angle itself, as long as it's between 0 and 90 degrees. For the next one, we have 135 degrees. If you draw 135 degrees in standard position, it will terminate in the second quadrant. And the reference angle here is 45 degrees. Now, the way we get 45 degrees here is that we know this angle here is 180 degrees. And so if we're looking at a 135 degree angle, the question is, how much farther do we have to go to get from 135 to 180? So the reference angle in this case, to calculate it, we just simply take 180 and subtract 135. And doing this gives us a reference angle of 45 degrees. So over here to the side, you'll notice a little summary. And right here it says, if theta is in the second quadrant, then the reference angle is always going to be 180 minus theta. And also, if theta is an angle in the first quadrant, then the reference angle is equal to theta. Again, assuming that the angle theta is between 0 and 360. But my opinion is you don't have to memorize this summary over here for angles. Just simply draw a picture, and then you will be able to see how to calculate the reference angle. And in the next example, we had an angle of 240 degrees. So again, 240 degrees, that goes past 180, but not quite to 270. So it's somewhere in the third quadrant. And the reference angle here is 60 degrees. Now again, the way we calculate this is we know that this angle is 180, and the given angle here is 240, so we're just basically finding the angle between these two. So the reference angle here is just 240 minus 180, which is 60 degrees. And for our last example, for an angle that is 330 degrees, first of all, that ends in the fourth quadrant when you graph it in standard position. To determine the value of the reference angle, which is 30 degrees, we just want to make note of the fact that this angle here is 360 degrees. The angle that we were given is 330 degrees. So to find the angle between those two, we simply take 360 minus 330, which is 30 degrees. So again, you can memorize these little formulas up here if you want for each of the 4 quadrants, but I think it's more productive to know the concept and just simply draw a graph each time you need to figure out a reference angle. The reason reference angles are important is because we have a reference angle theorem. The theorem states that a trigonometric function of an angle and its reference angle differ at most in sign. So what does that mean? They differ at most in sign. Well, here's what it means. Let's suppose that the cosine of a particular reference angle was equal to the square root of 3 over 2. Any angle theta that has theta hat as its reference angle will also have a cosine equal to the square root of 3 over 2, but it could be positive or negative depending on the quadrant that theta is in. So if I have an angle and I want to know the trig function for that angle, let's say angle is a large angle, all I need to do is think about, well, what is the reference angle for that angle? And if I know the trig function of that reference angle, then I can easily find the trig function of the angle by knowing what quadrant the angle is in. So let's do an example over here to the side to make sure we understand this concept. So here we want to find the exact value of 240 degrees. So our angle theta is 240 degrees. So what I want to do first of all is find the reference angle for 240 degrees. Now we did this on the previous page, but let's just go ahead and go through it. So here's 180 and here's 270. So 240 degrees is somewhere about here. To find the reference angle, we need to look at the angle between the terminal side of theta and the x-axis. So this angle here is 60 degrees, and we get that by subtracting 240 minus 180. So our reference angle is 60 degrees. So if I want to get the sine of 240 degrees, I first need to know what is the sine of 60 degrees. Well, the sine of 60 degrees is radical 3 over 2. You can calculate this value any number of ways. You can use the definition of trigonometry for right triangles. You can use the original definition, etc. Okay? But one thing we should know is the sine of 60 degrees is square root of 3 over 2. So that means the sine of 240 degrees is also going to be square root of 3 over 2. The only question is it positive or is it negative? Well, since the original angle 240 degrees is an angle belonging to the third quadrant, and since in the third quadrant sine is negative, the sine of 240 must be negative square root of 3 over 2. Let's try another example. So here we want to find the exact value of the tangent of 315 degrees. So my angle theta is 315 degrees. I need to find the reference angle for 315 degrees. So just like before, I'm going to draw my angle in standard position. So just draw an X and Y axis. We know that this is 180, this is 270, this is 360. These are all in degrees. This is 90, right? So when I go to graph 315 degrees, we can see that it ends up over here in standard position. So the angle theta hat, the reference angle here, is 45 degrees. And the reason it's 45 degrees is because we can subtract 360 minus 315. So our reference angle is 45 degrees. So the tangent of 315 degrees will be the same as the tangent of 45 degrees, except that we'll have to decide whether it's positive or negative. Well, the tangent of 45 degrees we should know is 1, right? And again, this should just be from memory. But if not from memory, you can use right triangle trigonometry to figure that out. And we can also see that the angle 315 degrees belongs to the fourth quadrant. And in the fourth quadrant, tangent is negative. So the tangent of 315 degrees is going to be -1. Let's try one more. So here we want to find the exact value of the cosecant of 300 degrees. Now, a couple of things here. To do cosecant of 300, I prefer to do 1 over sine of 300 because I know about the sine function more than I know about the cosecant function. So most people are more comfortable with sine versus cosecant. But the fundamentals don't change. The angle that we have is 300 degrees. So first thing we need to do is find the reference angle. So we know that this is 270 and this is 360. So to do the reference angle at 300, which looks like this, that reference angle is going to be 60 degrees. So we'll once again notice that 300 degrees belongs to the fourth quadrant. And to find the cosecant of 300 degrees, I have expressed it using sine of 300 degrees. So to get the sine of 300 degrees, that's going to be pretty much the same as sine of 60 degrees. Sine of 60 degrees is the square root of 3 over 2. Again, this is from memory, hopefully. Therefore, the sine of 300 is also going to be square root of 3 over 2, but we have to decide whether it is positive or negative. Well, in the fourth quadrant, sine is negative. So sine of 300 is negative radical 3 over 2. Now, this isn't our answer, though, because remember, we're trying to find the cosecant of 300. And we said that it's equal to 1 divided by the sine of 300, and the sine of 300 is negative radical 3 over 2. And so this is going to be -2 over radical 3. And you can leave your answer like this if you want. Or you can rationalize. And to do that, I'm just going to multiply by radical 3 over radical 3. And this is -2 radical 3 divided by 3. So you can leave your answer like this, or you can write your answer like this. Both are acceptable. Now let's talk about coterminal angles. The definition of coterminal angles is that two angles with the same terminal side are coterminal angles. So we have a couple of examples down here. The angle 10 degrees, right, 10 degrees, is the same as 370 degrees. And that's because 360 degrees is here. And if you go 10 degrees beyond 360, you get to 370. So 10 degrees and 370 degrees are coterminal. Now, there are many other angles that are coterminal with 10 degrees and 370 degrees. For example, we could have started at 0, and I could go in the negative direction. And this angle here would be -350 degrees, right? Because it's not quite negative 360, which would take us all the way back to the beginning. It's 10 degrees short of going all the way around. So negative 350 degrees is also coterminal with 10 degrees and 370 degrees. Now, what I want you to see about these coterminal angles is that you can always get from one angle to a coterminal angle by adding multiples of 360 degrees, right? So to get from negative 350 to positive 10, I add 360 to negative 350, and that gives us 10. To get from 10 to 370, again, I add 360. And that's just because 360 degrees is a full revolution. So no matter what angle you are currently at, if you add 360 degrees, you will be in the same place. So if I have an angle theta, the angle theta plus 360 degrees multiplied by k, where k is an integer, these angles are coterminal angles. And it doesn't matter if k is positive or negative, because if k is positive, that means you're adding multiples of 360 degrees to your angle. If k is negative, that means you're subtracting 360 degrees. So you can see just as easily, I hope, that to go from 370 degrees to 10 degrees, you would subtract 360. And to go from 10 degrees to negative 350 degrees, you would also subtract 360. So when you have an angle theta, adding or subtracting multiples of 360 degrees to that angle theta gives you a coterminal angle. Now we have another example here. We have the angle negative 45 degrees, which is this angle here. And then we have the angle 315 degrees. Those two angles are coterminal. Now, once again, to help you see this, if you take negative 45 degrees and you add 360 degrees to it, you get 315 degrees. So given any angle theta, you can always find a coterminal angle by adding or subtracting 360 degrees as many times as you need to. Now, to help us understand why this is important, if I have an angle theta plus 360 times k, the sine of that angle is the same as the sine of theta. That is because the angle theta plus 360k and the angle theta are coterminal. So basically, for trigonometric functions, coterminal angles are kind of like the same angle. Same thing here for cosine. Cosine of theta plus 360k is equal to cosine of theta. And just to be fair, this is true for all of the trig functions, not just sine and cosine. All right, let's take a look at the first example. Here we're being asked to find the exact value of the cosine of 495 degrees. So 495 degrees is an angle that is larger than 360. But if I can find an angle smaller than 495 that is coterminal with 495, I can use that angle instead. So if I take 495 and I subtract 360 degrees, I get 135 degrees. So cosine of 495 is the same as the cosine of 135. Now, how do I find the cosine of 135? Well, I'm going to graph 135 degrees in standard position, which looks like this. And then I'm going to find the reference angle here, which is 45 degrees. And I get that by taking 180 degrees and subtracting 135 degrees. And then I have to decide, is it positive or is it negative? Well, 135 degrees is in quadrant 2, and cosine in quadrant 2 is negative. So I'm going to pick negative here. And now to finish this problem, I have negative, and then the question is, what is the cosine of 45 degrees? Now again, from memory, we should know that it's 1 over radical 2 or radical 2 over 2. So our answer is either negative 1 over radical 2 or negative radical 2 over 2. Next, let's just talk about approximations briefly here. If your angle is not a special angle, then finding a trig function of that angle is something that you do on a calculator. So what that means is that if your angle theta does not have a special reference angle. Now let's think about this for a second. Special reference angles are angles that are 30 degrees, 45 degrees, or 60 degrees, right? So if you have an angle like 250 degrees, the reference angle for 250 is 70 degrees, right? So the reference angle here is 70 degrees. That's not special. You won't be able to find the sine of 250 without using the calculator, because we don't know anything about 70 degrees, right? We only know about sines, cosines, and tangents of special angles, namely 30 degrees, 45 degrees, or 60 degrees. So a little bit of good news here. If you don't have a special angle, in other words, if you don't have a reference angle that is special, then you simply plug it into your calculator. So to do this, you want to make sure that your calculator is in degree mode. And to take the sine of 250 degrees, all we have to do is plug it into our calculator. Now, in some calculators, that means that you are going to type the angle first and then the sine. But in most modern calculators, you will type the sine first and then the angle 250. And we usually round to the nearest 10,000th, which means 4 decimal places. So you should probably pause this video, take out your calculator, and make sure that you know how to type in all these into your calculator. So just get a little practice with that, and then we'll move on to the next piece. Okay, so if you had some practice with that, let's talk about some other examples. So down below here, we have cosecant, secant, and cotangent. And in this case, all of 250 degrees. So the question is, how do you type these into your calculator? Well, the cosecant, we have to remember, is 1 over the sine, right? Because we don't have a cosecant button on our calculator. So to get the cosecant of 250 degrees, we do 1 divided by the sine of 250 degrees. Now again, for most calculators today, you'll be typing it in like this. Maybe some of you have calculators where you type it in the other way. You need to get some practice, and you need to make sure that you can get the correct answer here. So normal calculators today, you will do 1 divided by, which is this part, and then you will hit sine of 250 and then enter. But for some people who might have an older version of a calculator, you might do it this way. But I kind of doubt it. I really think most people will be doing it this way. Now, get practice with all of these examples here. So next we have secant of 250. Secant is 1 over cosine. So it's going to be 1 over the cosine of 250. You enter it into your calculator very similarly to the previous example. And then lastly, we have the cotangent of 250, which is 1 over tangent. And again, double check, make sure you can get these answers. And if you're really not getting those answers, no matter what you do, I just want to remind you to make sure that your calculator is in degree mode. All right, let's move on. Now we're going to reverse the procedure. So here I ask you to find an angle theta if the sine of theta is negative 0.5592 and theta is in the third quadrant. And theta, they tell us, is an angle between 0 and 360 degrees. All right, the key here is you need the reference angle. Now let's see why you need the reference angle. You know that this angle is in the third quadrant. So we know the angle is somewhere down here. All right, so this is the angle theta that we are looking for. If we know the reference angle, which is this angle here, then the angle theta that we are looking for is simply 180 degrees plus that reference angle. Okay, so that's literally the answer to the question. We need to figure out the reference angle. So how do we do that? Well, this is how. We know the sine of theta is negative 0.5592. If that's true, then the sine of theta hat, the reference angle, has to be positive 0.5592. And that's because reference angles are always positive acute angles. So when you have a trig function of a reference angle, it can never be negative. Now on our calculator, we can solve for theta hat by doing the inverse sine of this value. And what we get here is about 34.0 degrees. And that's rounded to the nearest tenths place. So now that we know that theta hat is 34.0 degrees, we can plug it in up here, and we get theta is 180 plus 34.0 degrees. And when you do the math here, we get 214.0 degrees. And this is an approximate value for theta because this reference angle is approximated. And just in case you're wondering here, when you type this into your calculator, you actually get 34.00049,045. So when you round this to the nearest tenths place, you get 34.0 degrees. All right, let's try some others. So here we have tangent of theta is negative 0.8541. Theta is in the fourth quadrant, and theta is some angle between 0 and 360 degrees. And we want to find theta to the nearest tenth of a degree. So again, I'll just start by drawing a picture. We know that theta is in the fourth quadrant, so theta looks like this. What we need to do here is find the reference angle, which is theta hat. So here we know this is 360 degrees. We know that this is theta. And we know that theta is equal to 360 degrees minus theta hat, right? So if we go all the way around to 360 and then we go back here this much, we end up at theta. So again, we need the reference angle. Well, we know the tangent of theta is negative 0.8541, and that means the tangent of theta hat is positive 0.8541. And then we can solve for theta hat rather, by doing the inverse tangent of this value. And so just type that into your calculator. inverse tangent of 0.8541, and what you should get here is 40.5006, etc. So we'll say that theta hat is approximately 40.5 degrees. And now if I bring this down here, we have theta then is approximately equal to 360 minus 40.5 degrees. And when you do the subtraction on that, we get theta is approximately equal to 319.5 degrees. So again, a couple of key concepts. Notice that I drew a picture to see where theta is. That helps me understand that the angle theta is the angle 360 minus theta hat. And then the other key point is when you have a trig function of an angle, whether it's positive or negative, for the reference angle, it will never be negative. It always must be positive. All right, let's keep going. So in this next example, we have find theta if the sine of theta is negative 1/2, and theta is in quadrant 3. And again, theta is between 0 and 360. So quick picture here. Theta is in the third quadrant, looks like this. So this is 180, this is theta. So 180 plus the reference angle theta hat is going to be theta, right? So we need to find the reference angle there. What do we know? We know that sine of theta is negative 1/2. Therefore, sine of theta hat has to be positive 1/2. Now, the nice thing about this one is calculator is not needed, right? Because we know that if you have a positive acute angle, theta hat, and the sine of that angle is 1/2, theta hat must be 30 degrees, right? We know this from memory. Now, if you struggle with that, you can, of course, plug this into your calculator, and your calculator will also tell you that this is 30 degrees. But we should know this. So now we can find theta. Theta is going to be 180 degrees plus 30 degrees, which is 210 degrees. And this is actually exact. This is not an approximation because we know the angle theta hat is exactly 30 degrees. Now for our last two problems, we're going to do the same thing, but we're going to look at the other trig functions, like cotangent, for example. So in this problem, we're told that theta terminates in the fourth quadrant. Theta is an angle between 0 and 360. And the cotangent of theta is negative 1.1106. Round our answer for theta to the nearest tenth of a degree. So again, I start with the fact that theta is in the fourth quadrant, which means that it must look something like this. So this is where theta is. We need the reference angle here, which is theta hat. And we know from this picture that theta is equal to 360 degrees minus theta hat. So let's find theta hat. Well, cotangent of theta is negative 0.1106. So cotangent of theta hat is positive 1.1106. So again, anytime you're talking about the reference angle, you cannot have a negative. The problem here is we don't have a cotangent button on our calculator. So if the cotangent of theta is 1.1106, that means the tangent of theta is 1 over that value, right? Because tangent and cotangent are reciprocals. And now that means that theta hat can be found by doing the inverse tangent of this value. And so now we just need to plug that into our calculator. So we take the inverse tangent of 1 divided by 1.11 0.06. And when you do this, you get 42.000321105, etc. So we're going to say that theta hat is approximately 42.0 degrees. And now from up here, that means that theta is equal to 360 degrees minus 42.0 degrees, and that is approximately 318.0 degrees. And our last example is similar. This time we're told theta terminates in the second quadrant. Theta is an angle between 0 and 360. Round to the nearest degree for theta if the cosecant of theta is 1.2361. So again, I start with the fact that we're in the second quadrant. So here's an angle in the second quadrant. This is theta. We know that this angle over here is 180. So here's the reference angle theta hat. So to get theta, theta will be 180 minus the reference angle theta hat. So what's the reference angle? Well, cosecant of theta is 1.2361. So that means cosecant of theta hat is also 1.2361, right? So this time there's no change between the two because the value was positive to begin with. So cosecant of theta hat is this value, but to find theta hat, we need to get rid of cosecant, and we don't have an inverse cosecant button. So we need to remember that sine is the reciprocal of cosecant. So sine is 1 over 1.2361. And from here, we can use the inverse sine function to get the reference angle. And so we type into our calculator inverse sine of 1 divided by 1.2361 equals, and I get 53.99795, etc. degrees. So to the nearest tenth of a degree, if I cut this off right here, this 9 is going to round this up, which is going to round the 3 up to a 4. So it's 54.0 degrees. So now what is theta? Theta is 180 minus 54.0 degrees, approximately. And when you do the subtraction here, you get 126.0 degrees.